The demonstration of brain plasticity has been an important factor in convincing neuroscientists that your behaviorally based treatment really does work. It's perhaps fairly obvious to say that to behavior analysts, the proof that the therapy works is in the behavior change itself, whereas to neuroscientists, the proof that the therapy works is in the change in the patient's gray matter. What are your comments on this issue? Is there a way to bridge these dramatically different methods of verification of effectiveness?
I couldn't agree with your basic point more. Not only does the clinical, that is the behavioral data, stand by itself, but it is the primary data in a clinical study. That's what a clinical study is about, a treatment effect, which is a behavioral effect. Obviously, demonstrating that an intervention has an effect on the nervous system does not increase the size of the behavioral or clinical treatment effect. You can have a treatment effect without a nervous system, apparent nervous system effect, or you can have a huge nervous system effect and no clinical effect. Either way, the important thing is the treatment effect, which is a behavioral effect. However, it is a fact that neuroimaging data can greatly facilitate the acceptance of clinical results. The presence of such a, quotes, biomarker, that is a hot term these days, is highly valued as an index that a reported treatment effect is real and not a placebo effect or an artifact, as if the existence of a change in the nervous system indicates that a treatment is not a placebo effect. In any case, the appearance of this type of data in the clinical literature has become progressively more common with the increasing sophistication of non-invasive neuroimaging and brain mapping techniques and the currently wide distribution of the equipment needed to obtain such data. For a behavior analyst, this can be quite vexing. If a study is rigorous, why is the clinical, that is, the behavioral data, not sufficient evidence of efficacy if the experimental design is strong? However, for clinical acceptance of non-traditional methods, the key is the resolution of doubt in a large proportion of these of the individuals in a field and the gatekeepers for reimbursement in the field. And it is simply the case that the opinions of these individuals are strongly influenced by the demonstration of central nervous system effects. A fairly vivid example of this comes from the history of CI therapy. By 1999, a few papers had been published on the effect of the treatment, largely by my laboratory. While the intervention had become fairly well known, very few therapists were attempting to use it. At that point, I was able to influence two groups in Germany with which I was collaborating to assess whether CI therapy effects produces effects on the brain. That was the group in the Humboldt University led by Hertha Flor with Bruno Kopp as the principal investigator, and a group at the University of Jena in the laboratory of Wolfgang Miltner, with the collaboration of Cornelius Weiler. The senior author on that was Joachim Liepert. One of the resulting papers, as I showed that in patients with chronic stroke, the primary motor area producing movements of an affected arm shrank by approximately 1/2 after stroke. But 2 weeks of CI therapy doubled the excitable area so that its size returned to normal. Its function wasn't normal. The patient still had a deficit, though improved, but the size of the excitable motor area had doubled. The paper was reported extensively in the media. Clinicians began to say, aha, CI therapy produces a marked change in the brain. Therefore, the treatment results previously reported must be real. And in fact, the rate of publication of papers on the clinical effects of CI therapy began increasing markedly, really markedly, indicating accelerating use of the technique by clinicians who hadn't been using it before, but had been aware of it. While I was appreciative of the increasing acceptance of the technique, as a person trained in behavior analysis, I was also fairly irritated by this whole situation. The treatment effect on behavior reported in the imaging papers were no different than those that I had reported previously. However, before clinicians could begin to accept CI therapy as a viable treatment alternative that could be taken seriously, it had been necessary to show that it affected the function of the brain. The implications of this example for the behavior analysis field are clear. It does not compromise the integrity of one's research to develop a collaboration with a neuroscientist with neuroimaging experience and expertise, and to add an imaging component to one's work. The presence of imaging equipment is so pervasive that this type of collaboration would not be too difficult to obtain, and the expense, while not trivial, is not great. It might be extremely annoying to have to do this, but it wouldn't be difficult, and the game is worth the candle.
It seems to be this is a path for collaboration between neuroscientists and behavior analysts,
Yes.
because behavior analysts can provide the task that will lead to a change in the brain that the neuroscientists can detect and record and display.
Exactly right.